Yo, how are we going? What is up, everyone? Yo, Isaiah's here, good man. We got a few of the regulars. I think Mr. Miraji is here. I'm trying to at him, but I can't at him. Where's Miraji? How's everyone going? Hope we're doing alright. Hope we're staying safe. Hope we're following the rules. No, no, Mr. Miraji's not here. He's like in the chat, I think. We're doing okay. Isaiah's doing good. We got our usual crew here. This should be not too bad. Welcome to Nutshell Maths for those that are new. We'll be trying to do this today, tomorrow, and Friday at 11 o'clock each day because in calculus we can't afford to lose any time. This is our first time doing like a proper kind of like a lesson on it rather than like a tutorial. So bear with us as we try juggle everything at once. Yeah, we're going to look into the argument of a complex number today, and if we get time we might move on to polar form, but we'll sort of just see how we're going. I don't want to overload you on the first day. I just want to give you a little bit of work. A couple things for those that are new. In terms of, if I'm looking this way, it means I'm genuinely reading the chat, so you can chat on the right hand side of your screen. All you need to do is make a free Twitch account. If you have Amazon Prime, you can get a free Twitch Prime subscription and subscribe to me. But if you don't, just make a free Twitch account, and then you can chat in the channel. I can read your comments and I can reply to them. Yeah, the best way to use these streams is to interact with it, right? If I'm just sitting here talking about maths and I've got no idea what people are saying or any questions, it gets boring for me and boring for you guys. And I forgot to get myself a glass of water. Sweet. So yeah, the best way to use this is to get sup Kate, is to get this open, this here on the left hand side of your screen. To get that, go to our Google Classroom. If you're not part of our Google Classroom, ask someone and join it if you want. I don't really care. I just didn't want to make it public just in case some randoms joined. But if you're from school and you want to join, that's fine too. So join the Google Classroom and you can access this document. I expect you to be just like any other lesson, have your books out in front of you, be working at a desk somehow or a table or something, and be writing notes as we go doing the problems with me. There will be time where I'll just say, do this problem, I'll sit back and I'll let you do it. And yeah, it's just going to be normal as. Alright, let's get straight into it. Some notices firstly. Assignments. Please pass this message on to everyone. But I've got it here. So assignment 2, the one we released a little while ago, that is still on Google Classroom. You can still see it. Let me show you. I had a couple questions about it. Complex number assignment 2. Isaiah, you see that? It's at the top. It'll always be at the top. All the notes go underneath it. But complex number assignment 2, you should be able to see that there. Please complete this as if it was due. Okay? Do it on refill or whatever, but I'm not going to really collect this, am I? It doesn't make much sense. Do it by next Monday, please. There's not that many questions. It's not that hard. We will cover everything by the end of this week, so you'll be able to do it. But I need you to be studying hard as if you're at school. So complete this by next Monday, please. And on Monday, I'll either upload the answers or I will do a stream going through the answers or something like that. Depends how we go. Even though Monday is technically the first day of your school holidays. So please complete this. After Monday, so the start of the school holidays, I will upload another assignment. You'll probably already see it if you're part of the big Google Classroom with all Year 13s or with all Calc students. I can show you that briefly here. Here. Oh yeah. If you go to the main calculus page, then you should be able to see this assignment here. Please complete this over the school holidays. I'll upload it as a PDF so that it's actually readable. I'll have a look at it as well. But I'm expecting you to get this done and bring it on the first day back next term. Okay, first day back. This is due first day back to school. You see this? So do it on refill. Do it tidily. If Ryan's in the chat, do it once and do it tidily. Right? If Hum's in the chat, don't do it over 50 pages. Just over 5 is fine. Complete the assignment. Hand it back to me, please. Right? Yo, Hamza brought me here. Good, good. Milk tea in the chat. Right, so that's the assignments. Please get those done. I cannot stress it enough. I'll do another post on Google Classroom, but if you can spread the word, that is much better for everyone. If you can just tell everyone around. Right? All good? Don't be dry, it's 11 a.m. Right, if there's no other questions, let's get straight into it. But that's essentially everything that we're talking about here. Cool. Right, let's put that over there. Let's get this all set up. Right, before you look at this left hand side of the screen, I want you to just listen for a second. Right? So also for those that don't know, if I'm looking down, it means I'm writing on the iPad, which will appear in front of you here. Look at that, magic. Right? So maybe I'll just tilt the camera down a bit so when I'm tilting down you can still see everything. Right, let's get into it. So before I look at this, I just want to talk about what we've done so far. So let's recap some notation. Recap some notation. And it's probably useful to copy this down into your notes book. Recap some notation. Let's say if z is some complex number, a plus bi, right? Let's say that. Can you see everything okay? Do I need to write bigger? Please tell me. Or if the sound needs to be up. Right, let's say z is a plus bi. Then we've learned that we can write z bar, z hat as a minus bi. And we call this, let's get a fancy pen. We call this the conjugate. And we've also learnt that z bar, like absolute value of z, but that's not absolute value, it's the modulus, right, is the square root of a squared plus b squared. We call this the modulus, which by definition means essentially the length of, right, the length of z. Okay. Right, bigger. I'm trying. Okay. So, these are the three things we've kind of covered. If z is some complex number, the conjugate of z is a minus bi, and we use the conjugate for two main things so far. We've used it for division. I know it's getting hard to see now. And we also use it for, let me just move this all, so we've got some more room. We've used it for division, and we've also used the conjugate for the conjugate root theorem. Theorem, where we say every complex root come in conjugate pairs. Right, so if one of the roots is a plus bi, the other one must be a minus bi. Okay? Good. This is what we've covered so far. Now, let's have a brief look at, we're going to learn a third one. Let me move my keyboard. We're going to learn a third one, or kind of fourth one. But before we do that, I just want to look at, if I plotted a plus bi. So, let's say I've got some diagram like this. And let's say z equals 3 plus 4i. Then I would plot this as 1, 2, 3, 1, 2, 3, 4. This complex number would look like this. Let me make sure it's a straight line. Okay. This complex number would look like this, where we could say that this side has a length of 4 and this side has a length not of 2, of 3. Right? So, if this is the case, then we could say that the modulus of z is the square root of 3 squared plus 4 squared, which would be 5, right? So the length of z is 5. You happy with that? This length here would be 5. You could do the maths there and figure that out. Right? Now, the beautiful thing is that we have a right angle triangle here. Let me get my little laser pointer. The cool thing is here that this part here is a right angle triangle, right? And with right angle triangles, we have a lot of power. Okay, we have a lot of power. Because when you know any two bits of information, like this, then you can find out all bits of information. So at the moment, we've used these two bits of information to find this one. But we could also use these two bits of information to find this angle. Could we not? And let's try that now. So I'm going to find this angle here. Let's call that angle theta. Okay? Oh, here's Miss Maraji. If you solve a polynomial with real coefficients, then only the complex roots will be in conjugate pairs. Yes, for sure. Look, chat's popping off with Maraji here. I sat down with him yesterday on the phone. We made a Twitch account. He's going to be super famous soon. I can see it coming. Right. So theta, this angle in here, let's call it theta. I don't know if you'll be able to see this. I put a little theta in there. Right. This angle, how could we find this angle? Well, we could do SOHCAHTOA, right? The tan theta. I don't want an equal sign there. I want to like this. Tan theta is O over A, right? I'm just so shocked. Tan theta is, in this case, the O is going to be 4 and the A is going to be 3. I might make this pen a little bit darker. And therefore, theta must be tan inverse of 4 over 3. Now, this should not be a problem for you guys. This is literally what I'm teaching my year 11s right now. How to use right angle triangles, right? And if, oh, I forgot to find my calculator. Here we go. Applications, FX, simulator, or emulator. Right, you see this? Here we go. If, be back to year 11. Right. Let me just change this to degrees for now so that we're okay. So if we go the tan inverse, please do this on your calculator with me, of 4 over 3, we get 53.13. Okay, so what we've done here is we've gone, look, with this right angle triangle created by this imaginary number, I could find the modulus, the length of, but I could also find this angle. Now, because we're doing calculus, we have names for everything, right? And this angle is called the argument. Okay. Is called. I always spell argument with an E, but there's not. Argument. This angle is called the argument. Okay. Right. This angle is called the argument. Now, have a look at this. These notes here, please. And I really think it's important that you copy this down that you see on the left here. Right? The argument of z is the angle between the real axis and a line joining z to the origin. So this line here, which is a plus bi, this angle between this axis and the straight line is the argument. Okay, it is the argument. So let me show you what this looks like, right? If I have, oh my gosh, any complex number that I plot like this angle is the argument, and we call it the argument of z. So the notation for this is argz, right? Argz is theta. Right, the notation of this is argz. Yeah, the notes are on your Google Classroom, 100%. So now, Mr. Maraji can correct me if I'm wrong, but the argument is always measured from this axis, right? It is always measured from this axis. Yeah, the argument is always measured from this axis. See, Mr. Maraji agrees. Good. So you can see here that if I did this, had a complex number that looked like this, the argument is actually here. This is the angle we care about. And we'll talk about this more later, but this is the angle we care about. But the angle we can actually calculate is this angle. This is the angle we can calculate. I'll do an arrow. This is the angle we can calculate, but this is the angle we care about. And so this is the angle we call the argument of z. Right? So far so good. Let's look at a couple questions and see what sort of happens. Right? Let's look at some questions and see what happens. Now each time I have a question, I'm going to draw what this looks like. So let's look at these three examples here. I'm going to scroll down a little bit. Let's look at these three examples here. Example number 1. Okay, let's look at this. We've got z equals root 2 plus root 2i. So let's plot this on a diagram. Let's sketch it, not plot, because plot means it's accurate. Sketch means I'm just going to loosely put it on here, right? So root 2 is on the real axis, so I'm looking like this. Root 2 is along here, so root 2 is, let's say that's there, and root 2i is still positive, so it's going to be something like this. Right, let's just say that I drew that nicely. Okay, it's a nice door, thank you. Okay. So we could even make this, I might blow this up a little bit, into a triangle that looks like this, where we care about this angle. We care about this angle. Hamza's taking notes too. Good, good, good. We care about this angle, and we've got these lengths. Now this is root 2, this is root 2. So when they're both the same lengths, you could probably figure this one out, but let's do it step by step. Tan theta is O over A, root 2 over root 2, which means we're doing the inverse tan of 1. Any number of itself is 1. That means theta equals 45. If you don't trust me, trust your calculator. Inverse tan of 1 is 45. Happy? So the argument, so we can say here, therefore, the argument of z is 45 degrees. Is 45 degrees. Cool beans. Now let's do B and C. So far so good. Well done, sir. Mr. Mirage is happy. Right? Let's do question B, please. So it's kind of different to class right now, right? I can't tell if you guys are following along or not, and I also can't tell if I say, alright, can you do these two now, and I sit here and not do anything, I can't tell if you're going to do it. So I'm just going to expect, please guys, do these two ahead of time if you want to, and I'm going to do it quite slowly, right? You're way better off to just give it a go, get it wrong, and then I'll go through it and you'll see why. Again, I'm going to plot this just to be safe, and I want to kind of discover it. Marissa says give them time. Right, I'll let you do these two. I'll come back in like literally seconds because I need to get a drink of water anyway. Right? I'll be back. It's also really warm. Right. So far so good. Hopefully you've done it. Right, let's see who's done it. We're doing modulus, yes. No, not modulus, sorry. Yeah, argument. Right, let's do it. So, if I plot this, if I'm looking at these parts, this part is the real, this part's the imaginary. The real is negative. So if the real is negative, it's going to be like -1 over here. And if the imaginary is negative, then it's going to be minus √3, which is somewhere over here. Like this. You can see that, can't you? So if we turned it into a right angled triangle, like we did above, we're going to have a right angled triangle that kind of looks something like this. It is confusing because they're both negative. So, let's calculate this angle, but that angle is not the argument, but we have to start with this angle. Let's go through it, right? So I'm going to label these sides that I've got here. So the imaginary is this √3, and the real is 1. Now I know these are negative, but when we're dealing with the triangle, we have lengths. Lengths can't be negative, so it's not going to be negative. And if you try to find the inverse tan and stuff of negative numbers, it's not going to work. Now in this case, they're both negative, so it'll cancel, but we aren't going to treat them as negative because lengths can't be negative. Right? So let's have a look at this. Tan theta is O over A. The O is √3 over A, which is 1. That means theta equals the inverse tan of √3. We can calculate that. Yeah, I'll mark the argument in 1 second. Let me just do this. Oopsies. But yes, good call. Good call. Of √3. And there you go, we've got 60. So, we've found that this angle here is 60 degrees. But that is not the argument. The argument is, if we scroll up and have a look, it is always measured, thank you, always measured from that line there. It's always measured from here. So, we need to go like this. Let's have a look back here. The argument in this case is, what nice color can we use? This part here. This is the argument of z. Right? You cannot hear me. This is the argument of z. Is that better? So we need to think about this. If you imagine I travelled from here all the way around to here, how many degrees would I have travelled? Right? I would have travelled 180 degrees, for sure. Now, we know that this here, we've just found this to be 60 degrees, huh? So if that's 60 and the whole thing is 180, this piece must be 120 degrees. Right? Let's do that. 180 minus 60 is 120. Right? But now we need to think one more layer. Right? If I just told you from, let's go here. If I just told you from here that spin 120 degrees, this would be the typical direction. If you say positive 120 degrees, this is what that means. But we want to go in this direction. So how could we imply that we go in the opposite direction? I'll wait for an answer in chat. How could we imply that we go in the opposite direction? Daishokusai's got it. Matt's got it too. Right? It's going to be a negative. Fantastic. Isaiah's got it too. So our argument is actually minus 120 degrees. And that's so, it really reiterates why the diagram is so important. Right? Drawing the diagram each time is really important. So therefore, the argument of z equals minus 120 degrees. Kate's with me. You guys okay? So far so good. Let's do the last one here. Yo, Pikachu with the big brain. On the money, Mr. Miraji. On the money. Right, exactly. Right. Yo, big brains. We got big brains in chat. Right. Yeah, I'm just going to do, what I'm going to do is I'm going to do this last one. And then I'll talk briefly on some identities we've just learned. Right. And I'll do one question and I'll leave it at that. I'm not going to go much further. So let's slowly do question C because it's kind of a unique one. And then we'll talk about what we've kind of learned. We'll do a quick recap. And again, I will upload this all onto Google Classroom, okay? Right. I'll keep that there on the screen as well so that you can kind of see that. Yo, thank you. Matt going hard. Right. Let's have a look at this. This is a unique case, isn't it? We have minus 2i. So on the real axis, which is this axis here, we've got nothing. Which means it's only going to exist on the imaginary axis, this complex number. Which is going to be at minus 2i. You with me here? Now, if I was to try and turn this into a triangle, we did this in class the other day, right? Triangle with no side, that's real weird. Right? But always remember back to, what is the definition of an argument? Right? And you can see it here. The argument is the angle between the real, positive real axis, and a line joining z to the origin. So, I've drawn a line joining z to the origin. You see that? And we say, what angle have we turned through from this point here, or this axis? What angle have we turned through? I want some answers in chat. What angle have we turned through from here to get to here? Some answers are correct. I'll plot some of the wrong ones that have been said. Someone said 45. 45 would be here. Someone has said 90. 90 would be here. Someone said 0. 0 would be here. Now we're getting there, aren't we? Minus 90. That's why the sign is so important, right? Because we have notation for a reason, so that everyone does the same thing. So when we say minus 90, we mean go in this direction 90 degrees. Good. So therefore the argument, we don't even need to do any maths on this, or any calculations. The argument of z is going to be minus 90 degrees. Right? Oh, Jimmy going hard with the minus pi by 2 radians. Good. Yeah. It is like talk. It's exactly like talk. Good. Right, let's recap what we've learned. And then I'll do one more. I'll see. Let's just talk very briefly. Right. I'll put this here. Some helpful identities we have just learnt. Okay. If the argument is 45 degrees, let's have a look up here. In this situation, the argument was 45 degrees. What was the A and B component, the real and the imaginary component? What was special about the real and the imaginary component of our complex number? When the argument is 45 degrees, what is special about the real and imaginary component? Moo's on it. Isaiah's on it too. They're the same. Right? And that is essentially a rule, right? Whenever we have two positive, in this case they're both positive, that's why we got positive 45 degrees. But if they were both negative, we would end up out here. If one was negative, one was positive, and one like this. But you're always turning this like 45 degree increment, right? But you can see 45 degrees happens when both, or when, let's say, A equals B and A and B are both greater than 0, right? When they're both positive. I just want us to kind of get this. Right? Yeah, Mr. Maraji's right. Pay attention. Tina's here too. Good. You can see this, right? This situation produced this. Now, knowing this is really important for excellence. Right? Knowing these sort of like little identities. I've had a look at some past exam questions. If you can pick this up, it's really good. Right? What else did we learn? What about this one? What was special about this one? If the argument is 90, then there's no real component. Exactly. Right? 90 or minus 90. No. Let's keep it looking the same. No real component. Fantastic. Right, the real component equals 0. Right, arg 0. Yeah, I was thinking about that. You're right. I didn't for the first one, and I couldn't be bothered changing it. But you're right, Mr. Maraji, as per usual. How's that? And then I can probably fit, if I move that very slightly. The beautiful thing about an iPad. Okay? So the argument of 0, the argument of z produces a real component of 0 when it is 90, right? Or when the argument of z is 90, we get no real component. Happy so far? Let's highlight this. You could probably from that last one, infer one more, right? I'm not going to write it down, but I'm going to ask you, what if the argument of z was 180? What does this tell us about the complex number? Yeah, Kate's on it. The imaginary is 0, right? It's purely real. Purely real and one other thing. Purely real and purely negative, right? Thanks for the follow. Will or Willie? Right. That's an important one to know too, but I've run out of room. Thanks, Moo. Right. Let's look at one hard question and then we're done. Okay? One hard question, then we're done. Or then I'm done. You've got 2 questions to do here. Yeah, we've got a little follow train going here. Now this question here is fun. I like it a lot. These other 2 are way more fun, but you might not like them a lot. But this one you should all be able to do. Can we please start this now? While I get all set up over here. While I write it out, you should start this and give it a go. Yo! Matt going hard on the bits. Thanks, dude. Huge follow train too. Right, let's look at this last question. And then we'll leave it at that. I don't mind just leaving it here. That means tomorrow we'll do polar form. So z equals, do you guys call it z or z? Z? Z, lots of z's. Z is 1 plus I, and W is 1 over Z plus I. He likes my identities. Woo! It's like, who's seen Howl's Moving Castle when the guy's like, he likes my spark? Anyone know what I'm referring to? Look it up if you don't. Right. Let's do this last one. Okay. First things first. Every time I do a math problem, I've shown you this, I've talked to you about this. Right? Every time we do this, I always say, what is the problem? What's the hard part about this? What makes this question difficult? And let's tackle that. Right? So, you can see this 1 over z, and I'm sure that's the part that you guys go, ugh, yuck. Right? So 1 over z is the gross part. That's the part we've got to tackle. Right? I'm feeling the compliments. Right? So let's have a look at this. W is going to equal, or let's not even worry about W. Let's do 1 over z is going to be equal to 1 over 1 plus I. Right? You always got to tackle the hard stuff, or the problem. You always think, what is the problem? Let's deal with that. So we all know how to do this division. And in fact, I gave you a hint at the start of this lesson how to do the division by reminding you. Oh my lord, Matt. Matt's going crazy. How do we do this division, please? I want one word. One word in the chat to indicate that you know how to do this division. One word. It's a special word. No, not cross. Oh, sort of. Yeah, conjugate was the word I'm looking for. Conjugate was the word I'm looking for. You will. Nah, cross multiply is wrong. That's just wrong. Conjugate's right. Whoa, Dark Evil's in chat. So, we're going to multiply by the conjugate, 1 minus I, over the conjugate, 1 minus I. So, when we do this multiplication, it's nice and easy because the top is easy. This is just going to be 1 minus I all over. This is the first one squared, the middle cancels out, plus the last one squared, which is 1 plus 1, right? 1 minus I all over 2. So that 1 over z part, we've just done there. we've only done this part here. Yeah? So let's say, therefore, W equals 1 minus I over 2 plus I, which I've just added on the I on the end. Where'd you get 1 over Z from? It's in the question, Isaiah. So if you look at this question here, the 1 over Z is in the question. So I've just pulled that part out of the thing just to deal with that. Okay. Big brain Matt. Now let's split this. 1 over 2 minus I over 2 plus I, because it's going to help us a little bit. This is where some of us might get confused. Now the real part is still just 1 over 2. What's minus a half plus 1? Right, which is the coefficients of I. Minus a half. If you're in doubt, just do this. I'm hoping you should know this. But we're going to have positive a half again, right? That I is a bit ugly. I understanding. Good. So far so good. This is facts, Kate. Yo, we're always speaking facts. So now we've got W. Right? We've made the question much nicer. Because the question is, find the exact value of argW. Right? The argument of W. So let's go. The argument of W is going to be, well, let's draw the diagram, right? Actually, something should like ring a little bell for you right now. Right? Something should ring a little bell for you right now. Look here. Right? 45 degrees is popping off in the chat. Right? If you want to double check, which I wouldn't be afraid to do, right? In my notes, I did this. I drew the diagram. I very quickly plotted it. So it's going to be both positive. This is a half, this is a half. So then, when we go to plot it, or when we go to do it, we're going to do, or let's make sure we know what we're doing. This is the argument here. Hopefully you can see that okay. 10 minus 1 of 1, because it's going to be half over a half. Which, in this case, or in all cases, is 45 degrees. Okay. Awesome. Now, these questions here separate the kids from the grown-ups, yeah? This separates the people that are going to be slack on isolation versus the ones that want to actually do well in their externals, right? So please, if you want to copy, you can copy, but I've uploaded it to Google Classroom, right? I've uploaded it to Google Classroom. Complete these two if you want to be a real beast, okay? If you just want to, maybe these aren't for you, but it's like the whole, are you a man or a mouse? Right, if you're a mouse, you'll write these into your notes and never look at them again. But if you're ready to go beast mode, if you want to do calculus, if you want to be an engineer, try these two here. We're going to stop there. That's been 45 minutes. It's pretty condensed. It's a lot of learning. Post up your classroom code. You should have all these notes too. I'm pretty sure. Ask someone in my classroom, 'cause I don't want to put it into a video because then I don't want, like, worst case scenario, a whole bunch of randoms join it and then it's like, I don't want to have to deal with that. Just follow and you get the notification. So tomorrow we'll look at two things. The first thing we're going to look at is complex number. The first thing we're going to look at, we've talked about all these angles and stuff, but we didn't talk about this pi by 4, what Jimmy has been saying in chat. Now, I feel like you've learnt a lot this lesson, so I'm just going to leave it. But for those that don't know about radians and degrees, it might be worth Googling it. So Kate, if you want to get ahead, Google some difference between degrees and radians. We'll start the lesson tomorrow by talking about that a little bit. We might even do one of these problems, one of these ones, and convert our answer into radians. It's good for you to be able to understand radians. Right, but at this moment, we'll leave it. Yep, so Miss Maraji says tell them pi is 180, right? So we'll start with that tomorrow, but just a brief heads up. If I have this diagram, we talked about how this distance is 180 degrees, and this distance we call minus 180 degrees. In radians, this distance we call pi, and this distance we call minus pi. Okay? Because a whole circle counts as 2 pi. We'll talk more in detail about that tomorrow. But this is like what you at the very least need to understand. So just like this is half of 180, i.e. 90. This is half of pi, which we just call pi by 2. Okay? It's just another way to describe the angle we turn through. In fact, it's a better way. I don't know. I like degrees. I always found radians kind of confusing, but I can understand their usefulness now. But we'll leave it at that. We're going to stop there. We've got 2 minutes for questions, and then we're done. That's a 50-minute period, basically, right? Okay. Tina's happy. Most of us are happy. If you found this useful, please let me know, but also tell other students. Right? We had, I think, like 35 people in here at one point, but I know some of us are in here that are not even doing calculus. But it looked like most of our class was in here, which is kind of cool. That's really good, actually. I don't know who's who, but most of us I can see. But yeah, if we keep having good attendance, then please, I'll keep going. If I'm always willing to put in more than what you guys are putting in. So if you put in the effort, I'll double it. I'll match it. What did you do at the start of example 2? I'll leave these notes here. But this is z, so we've got 1 over z. Right, 1 over z. I just pulled that out over here just to deal with that. Right? So I'm just doing the division of 1 over z. Right? The division of 1 over z is, or 1 over z, is 1 over this, which becomes here. And I do that division by multiplying by the conjugate over the conjugate. That's answering Isaiah's question. Let me know if that helped Isaiah. Yeah, did good. Yes, Daishokusai, the assignment is due for everyone. Okay. I don't know what he said there. He got banned. Yeah, the assignment that Mr. Subramani has posted on Google Classroom for everyone is due. Assignment 2 for my class, and I think your class, is due on the normal due date. Just get it done. We'll put the answers up. Just get it done. Oh yeah, I banned teachers' names. That's why. Sorry. HSL. Thank you guys for watching. Thank you, Mr. Maraji. Right. Thanks for participating properly. It's been really helpful. Willie, yes, I am a teacher, by the way. I saw your question. Sorry. Thank you, Kate. Understood. If you got any questions, just flick me an email, or if you're unsure, please just post it on the Google Class because other people have it. Thank you, Mr. Maraji. Appreciate it. Matt's popping off with the cheers. Matt's cheering like no one's business. 10 bits, 70 bits, 7 bits, 10 bits, 2 bits, 1 bit. You'll be close to the top soon. Yes, I'm streaming at 1 PM for level 1. Isaiah, tell your brother. Yep. Quantum, see you later, my dude. Well, you could have been playing cricket. Oh, but Mr. Raji. Right, I'm gonna zip out. I'll go have a break. Brian's just popped in just to say goodbye. What topics will you cover in the future? It's all on the stream schedule, which will appear when I shut it down. But basically, I'm just doing calculus for the next 3 days. We're doing complex number in polar form, which is all here. This is a sneak preview. And we'll be doing using polar form to do multiplication and division. And later on, looking at Demois's theorem as well, if we get enough time, which I think we should. And I'm also doing level 1 streams, which will be talking about linear algebra, straight line graphs, basically. How do you know if you did 3 right? You got an answer, Kate? I got an answer. Question 4 is a prove, right? So you'll know when you get it right. Question 3, the answer is 2. So, there you go. I've only told you the answer, so you can double check. Question 3, the answer is 2. K equals 2. And question 4 is a proof, so you can just figure it out. This one's actually easier than it looks. Both of them just took me 1 page of working. Alright. Thanks, guys. See you tomorrow. I'm all done. I got to prepare for the next stream at 1. Thanks for tuning in. Really appreciate it. You're getting a quadratic for... Yeah, you should get a quadratic. And then you think about it. If 2 is one of your roots, or one of your values for k, then you're on the right track. See you tomorrow, Willie. See you guys tomorrow. Thank you once again. See you later.